After decades of steady decline, a dramatic resurgence of tuberculosis occurred in the United States in the late 1980s and early 90s. Although this recent rise in the number of tuberculosis cases has been brought under control, the occurrence has heightened our awareness of the importance of timely and accurate laboratory testing. Because of this heightened awareness, more laboratories are processing more specimens. However, many laboratory personnel have not had extensive experience or the opportunity to develop strong competence in mycobacteriology testing. Such deficiencies could lead to an increased likelihood of procedural lapses and the possibility of false positive test results. As more specimens are processed, the risk for carryover of organisms from specimen to specimen increases. This program focuses on helping you achieve accurate test results in mycobacteriology by showing you how to recognize conditions that might lead to false positive tests and providing you with strategies to eliminate or modify them. To help us distinguish between effective and ineffective lab practices, I'd like to introduce George. He will be helping us throughout our program. So, George, what do we need to do?
Well, here's our job. We need to give the viewers the information and resources so that after viewing this videotape and studying the accompanying booklet, they will be able to recognize when false positive results occur, recognize points in the testing process where contaminants are most likely to be introduced, evaluate laboratory practices that might contribute to false positive results or cross-contamination, describe and demonstrate practices that will minimize the chance of introducing contaminants.
Great. Sounds good to me.
Feel free to stop the tape at any point to review material, examine the booklet, or discuss the material with your colleagues.
What does false positive mean to you, George?
Well, a false positive means that the test results on a patient's specimen are reported as positive for a species of mycobacterium when in reality the patient does not have that particular mycobacterial infection. A false positive result may occur and be reported when a specimen has been contaminated before or during a testing procedure with other acid-fast organisms not originating with the patient, or when patient records or test results have been recorded incorrectly.
Contaminating acid-fast organisms can be introduced into specimens throughout the testing procedure, beginning with specimen collection. The contaminating organisms can originate from other patients, other specimens or testing samples, or from the environment.
Did you know that reports of false positive rates in mycobacteriology vary in different studies, with rates as low as 0.2% to over 30%? What variability! And these rates can be expressed in different ways. As a percentage of M. tuberculosis isolates that are recovered from persons who don't even have tuberculosis, and also as a percentage of sputum specimens that should be negative but somehow become contaminated with acid-fast bacilli. False positives can cause a lot of problems for a lot of people.
What kinds of problems can occur if inaccurate test results, such as false positives, are reported to the physician?
Well, let's see. The patient could be managed incorrectly by being treated with drugs unnecessarily or by being placed in isolation. The laboratory may be required to do unnecessary testing, not only increasing the workload, but increasing the testing cost. And finally, the credibility of the laboratory, hospital, or the physician may be questioned.
How do you know that false positives might be occurring in your laboratory?
Some typical signs of a false positive problem are a sudden increase in the number of isolates of a particular organism, or no correlation between the isolate and clinical signs of disease. Maybe a discrepancy between smear and culture results. The appearance of a cluster of positives in which one specimen becomes positive, and several days later, sequential specimens become positive. Or if you see fewer than 10 colonies recovered from only one of multiple specimens submitted from the same patient.
It is important for you to recognize when you have a problem with false positives. We'll discuss these signs in more detail as the video proceeds, but keep these signs in mind as you think about your own experiences with the TB testing process.
Let's take a quick review of the laboratory testing process and the events that might cause a false positive result to be reported. Collecting the specimen, receiving the specimen in the testing laboratory, logging it into the record system and assigning a number, processing the specimen, adding reagents, centrifuging, staining and examining smears using acid-fast microscopy, inoculating culture media for isolation, identification of the isolate, entering test results into the patient's records, and reporting results to the attending physician.
The testing process certainly has a lot of parts, doesn't it?
Oh, you bet. It's very important that each task in the testing process be performed in such a way so as to ensure the integrity of the patient's specimen is retained, the records accurately correlate test results and patient information, and that no contaminating acid-fast bacilli from other specimens or from the environment have been introduced at any point during the testing process. Let's see how good you are at identifying potential causes of false positives by following a specimen through the laboratory testing process. In your booklet, you'll find an observation worksheet. As you watch the tape, you'll see incidents that could potentially lead to false positive results. Each time you believe you've seen a potential problem, place a little check mark under the appropriate column on the worksheet. Are you ready?
A specimen arrives at the laboratory and is logged into the laboratory records. Reagents are prepared. The biological safety cabinet is ready for processing specimens. Smears are prepared. Smears are air-dried and heat-fixed. After fixation, smears are stained. The stained smears are examined microscopically. Both solid and liquid media are inoculated with samples of the concentrated specimen. Periodically, during incubation, all cultures are checked to detect the presence of growing organisms. Culture growth is identified using DNA probe technology or high-performance liquid chromatography. Test results are correlated with the patient entry in the login system and then entered into the laboratory record. The physician must be notified of the test results quickly.
Hello, Dr. Wright. This is Precision Labs calling with the test results on Robert Brown. He tested positive for tuberculosis.
Oh, I don't understand that. I don't have a patient name.
How many incidents did you see? You should have been able to spot at least 13. Let's go back through the procedure and discuss the laboratory practices you saw.
Prevention of false positives begins with the careful collection of the specimen. Contaminating acid-fast organisms can be introduced into the patient's specimen during the collection process. It is essential, therefore, that all materials, reagents, and equipment used in collecting the specimen be sterile and free of contaminating organisms. Contamination during collection could result in early mismanagement of the patient. Such contamination could be reflected throughout the testing process and could result in a lot of unnecessary testing. Because specimen collection is not done in the laboratory, we will not be discussing it in this program. It is important, however, to be aware that contaminants can be introduced when the specimen is collected. Let's start with the first phase of the laboratory testing process.
Do you remember this scene from the observation exercise? Did you notice the incorrect entry of the patient's name? Roberta Brown was entered as Robert Brown.
That could be serious. Correct correlation of the patient's specimen with laboratory records is critical. Inaccuracies during specimen login could result in erroneous information being transmitted to the physician. To prevent this type of problem, personnel must be conscientious, work without interruptions, and develop an internal fail-safe mechanism, for example, barcodes for verifying the entries.
Now let's look at the next step, specimen processing. It is critical that when processing specimens, the laboratory area is restricted. Personnel must be trained and know how to perform tasks safely. They must be able to recognize conditions that lead to cross-contamination of samples or infection of workers. Universal precautions must be taken, and personal protective equipment must be worn. It is essential that specimens be processed in the biological safety cabinet.
Cross-contamination occurring during specimen processing will be reflected in all the subsequent steps of the testing process, from smear evaluation to isolate identification, and, if done, susceptibility testing.
What did you see in this part of the process? Remember? What about the water?
Standing water, such as found in holding containers and in the pinched end of the delivery tubing, is a notorious breeding ground for contaminants. Avoid storing water in large containers. Always flush the delivery tube before dispensing the water. One of the most common sources of contamination by acid-fast organisms is tap water. Water is often used for rinsing equipment, rinsing a patient's mouth, making ice, preparing reagents, and so forth. A suggestion for testing water for the presence of acid-fast organisms is found in the booklet that accompanies this video.
Do you remember this scene from the observation exercise? The airflow on the Biological Safety Cabinet, or BSC, is not drawing inward. The flutter strip is not moving, and the magnehelic gauge reads 0. Not only should that paper strip flutter into the cabinet, indicating flow away from the worker, but the cabinet's magnehelic gauge should register at the expected level. Without the proper airflow in the BSC, aerosolized pathogens might escape the confines of the safety cabinet. Accidental splatters could contaminate work surfaces, even other specimens, or maybe even you. Never work in a BSC when you are uncertain about the airflow.
You're right.
Remember, BSCs should be certified at least annually by authorized technicians to assure the correctness of the airflow. Do you remember this scene from the observation exercise? Something's wrong here. Where's that disinfectant-soaked towel?
Drops or spills falling on hard surfaces can splatter long distances, creating aerosols which can contaminate work surfaces, specimens, or you. Always work over absorbent toweling soaked with disinfectant. Should liquid drop onto the work surface, the wet towel will absorb the spill, reducing the production of aerosol by as much as 90%. Make certain that the toweling does not block any of the BSC's intake or exhaust ports.
And what do you expert laboratorians think of this worker's techniques?
When more than one specimen-containing tube is open at a time, the stage is set for potential cross-contamination. Droplets created when working with one specimen may potentially contaminate the contents of another specimen tube or fall on the interior of the upturned caps, subsequently contaminating that specimen sample when the cap is replaced. When recapping the tubes, caps may be placed accidentally on the wrong tube. To prevent this mechanism of cross-contamination, caps should remain on all tubes except the tube on which you are working. It is critical that only one tube be open at a time and that caps be kept with the inside surface down.
Okay, what's wrong here?
When the digestant is poured into one specimen-containing tube, a chance exists for splashback from a potentially positive specimen up into the neck of the vessel containing the digestant. This technique provides a mechanism for transfer of organisms from one specimen to another. The direct lip contact of the two containers also facilitates transfer of organisms from one vessel to another. Not only must you think of protecting your specimen or testing sample from being contaminated with organisms, but you must also guard against contaminating your reagents as well. One way to avoid this type of cross-contamination is to pre-dispense your reagents into single-use volumes. For example, digestant, approximately 10 milliliters per container. Buffered water, approximately 50 milliliters per container.
In summary, it is critical that no mechanism exists for one specimen to contact another.
The proper technique for removing the caps from tubes and adding contents from one tube to another will be demonstrated for you. Notice that only one specimen tube is open. How the cap on the specimen-containing tube is held with the interior surface kept down. How only one reagent tube is open. How the reagent is poured carefully down the side of the tube to minimize the production of aerosol. In the observation exercise, the mixing and centrifugation steps were done correctly. A vortex was used for mixing, closed safety carriers were used for centrifugation, and following centrifugation, the carriers were opened in the BSC.
Oops! That specimen may have been cross-contaminated, or the mycobacteria killed by the disinfectant in the solution.
When pouring off supernatant fluids, avoid splashback of potentially infectious organisms from the waste fluid in the discard container.
One way of preventing this problem is to pour liquids down the sides of a funnel placed into a larger container. Another preventive measure is to process all known or suspected positive specimens last.
Let's look at some of the features important to acid-fast microscopy. Acid-fast microscopy is the first, easiest, and most rapid test performed in the mycobacteriology laboratory. Based on microscopy results, the physician may isolate the patient, initiate drug therapy, or request additional laboratory studies on the patient's family and close contacts, or take all of these actions. A false positive test could cause worry for the patients and expense for the laboratory, especially if the new direct nucleic acid amplification test is used.
Look at this! Did you spot those dirty, greasy slides? Doesn't that worker know that grease may coat non-acid-fast organisms, making them retain the stain. That dust and dirt may contain environmental acid-fast organisms, that scratches and old slides can retain organisms and debris.
Yes, you should always use new, clean, unscratched slides. Before use, you can clean slides by wiping them with 70% ethanol and allowing them to dry. Do not mark slides with wax pencils or any other substance that may flake off and cause problems when the stained smears are evaluated microscopically. Do use lead pencils or barcode labels to put identifiers on the slides.
To avoid later confusion when correlating test results with patient records, be certain that slides are labeled with sufficient identifier information so that no questions exist as to specimen source.
Throughout the testing process, it's critical that the test results are linked to the identity of the patient and to other tests being performed on the same specimen. Events in this scene were done correctly. When making smears, it is important to air dry them and place them on a slide warmer within the BSC for fixation. Heat fixing, even for 2 hours, does not necessarily kill the mycobacteria, nor does it guarantee that organisms will stay attached to the slide. Not only may they be alive, but they may be capable of cross-contaminating other slides. If slides touch one another on the staining rack, particles or organisms can be transferred from one slide to another. In order to prevent transfer of organisms, place slides on the staining rack with sufficient space between slides to allow reagent fluid to readily run off into the discard pan. For the same reason, never use bulk staining methods for acid-fast microscopy. Did you notice the carboy of water, the pinched rubber tubing? Remember, tubing with pinch clamps, carboys, storage tanks, or closed water taps, any place where water is allowed to stand, are potential breeding grounds for mycobacteria. Rather than using standing water from a jug, it is better to attach tubing to the cold water tap and flush the system before use, or to use slow-running tap water for rinsing the slides. If your water supply is contaminated with AFB, a membrane filter placed in the supply line should remove the organisms.
The daily use of both positive and negative control smears should detect reagent contamination and ensure that the stain is working properly. A false negative report on a smear could be just as detrimental to the patient, if not more so, than a false positive report.
In today's dynamic world of mycobacteriology, rapid systems that isolate most mycobacterial pathogens in a shorter time are constantly evolving. As new methods are incorporated into the laboratory, each step should be examined to determine if any manipulations could lead to cross-contamination. In this scene, notice that the BSC is properly equipped. Discard containers for labware and sharps, disinfectant-soaked towel on the work surface. Note, too, the worker is wearing the proper personal protection equipment, gown, respiratory protection, and gloves. Observe that both liquid and solid media are being inoculated correctly, in this case, Bactec 12B and Lowenstein-Jensen. Use of both solid and liquid media increases the sensitivity of the isolation process. Notice the precautions that the worker is taking. Checking the labels on the specimen concentrate and culture media that is to be inoculated to make certain they are identical. Opening only one specimen tube at a time. Making certain that the needle is permanently attached to the syringe. Swabbing the septum with disinfectant after the bottle has been inoculated.
Look at this. Careful handling of the inoculated Bactec bottles prior to testing is critical. Avoid contaminating the underside of the septum with a culture medium that may contain infectious organisms. Contamination of the septum can transfer contaminants to the sampling needles, which may then contaminate other cultures. This situation shows a problem that can occur when testing. Needles should be changed daily. Be certain they have been cleaned, inspected for burrs and other imperfections, and autoclaved according to manufacturer's recommendations. Make certain the media trap is installed correctly. Newer models of the Bactec 460 have directional arrows to show proper alignment of the trap. The trap, filter, and tubing should always be kept clean and changed periodically as recommended by the manufacturer.
What about this situation which happened when loading the Bactec 460?
Uh-oh, he forgot something.
Before sampling, the culture vial's septum should be wiped with 70% alcohol. After sampling, the septum should be wiped again, first with a tuberculocidal disinfectant, followed by 70% alcohol. Potentially any organisms on either side of the septum can be transferred to another bottle via the sampling needle. 70% alcohol used as a second wipe of the septum has additional antimycobacterial action, but works here primarily to remove the more sticky residue of the first disinfectant. The small residue of 70% alcohol evaporates quickly, leaving a clean septum.
Do you know of anything else that might help our viewers detect or prevent false positives?
As a matter of fact, I do. Other suggestions for the prevention and early detection of problems when using Bactec include: place 1 or 2 uninoculated bottles of medium within and at the end of each run to detect any carryover of organisms and to allow a final heating of the needles. Separate cultures that you know or suspect to be positive, such as cultures that have already shown growth, cultures of smear-positive specimens, and cultures of proficiency testing samples from cultures of unknown status. Place these positive cultures at the end of the run. Always read and follow the instructions provided by the manufacturer. They were written to help you.
Now let's consider another kind of contamination. Thus far, we've been thinking of false positives primarily in terms of contamination of a Mycobacterium negative specimen with an acid-fast organism. Another example is one in which we have a specimen or testing sample that contains a legitimate acid-fast pathogen that is contaminated with yet another acid-fast organism, resulting in a mixed culture.
Contaminating organisms can overgrow the true pathogen, masking its presence. Instead of detecting and identifying the true pathogen, it might be the identity of the contaminant that would be recorded in the patient's records and reported to the physician. It is therefore imperative that the species of Mycobacterium identified from the specimen actually originate with the patient. Always check the isolate to make sure you are working with a pure culture before you perform identification tests. An occasional source of false positives is the incorrect entry of laboratory information. A wrong name, a transposed number, incorrect transmission of laboratory results could all lead to the wrong patient being diagnosed with the wrong disease. Double-checking all entries after completion of the data transcription will help guard against mistakes.
Hello, Dr. Wright. This is Precision Labs calling with the test results on Robert Brown. He tested positive for tuberculosis.
Oh, I don't understand that. I don't have a patient named Robert Brown. Do you think there could be a mistake with this?
Such a simple mistake, but one that could prolong the diagnostic process unnecessarily. The patient may need to be recalled in order to collect a new specimen to begin the testing process anew. A well-designed practice of cross-checking is very helpful in the early recognition of false positive reactions. Quality assurance practices can prevent problems, including false positive results. Such practices include: never use any reagents past their expiration date or recommended shelf life. This includes reagents prepared in-house. Make certain that reagents are stored at the recommended temperature. And always test a new lot of reagents in tandem with an established lot to make certain the new lot is performing correctly. Some of the common clues that should provide reason to pause and assess your laboratory practices include: the occurrence of a discrepancy between smear and culture results, especially a specimen that is smear positive but culture negative. Because cultures may be as much as 1,000-fold more sensitive than smears for detection of acid-fast bacilli, Virtually every smear-positive specimen from a patient not on therapy should also be culture positive. The late appearance of clusters of positive cultures, which show either scanty growth of less than 10 colonies on solid medium or a delayed elevation of the growth index on the Bactec system. While these results may be observed in patients receiving a successful regimen of anti-tuberculosis therapy, most newly diagnosed patients usually provide more strongly positive results. The recognition of large numbers of isolates of a particular organism, for example M. gordonae, may suggest a common aqueous source for this normally environmental species. Other species sometimes detected as contaminants in water, which are also potential human pathogens, include M. avium complex, M. scrofulaceum, M. cheiloni, M. fortuatum, M. xenopi, and M. kansasii. Repeated, unexpected isolation of these species from several patients suggest contamination. Only one positive culture from a patient. Establishment, maintenance, and frequent reference to laboratory data may help the laboratorian to pinpoint and quickly focus on the possible source of a problem. In your booklet, you will find suggested record-keeping tools for data organization. Specific biochemical and drug susceptibility test patterns and restriction fragment length polymorphism, or RFLP testing, also known as DNA fingerprinting, can be valuable in confirming that cross-contamination has occurred.
Contact your state health department laboratory for assistance in referring samples to an RFLP reference laboratory.
Although it isn't possible to ensure that cross or environmental contamination will never occur, it is possible to greatly minimize the chances of contamination by following the guidelines presented in this videotape.